So here, let us look at a few more examples. Those examples are I made by myself. The solutions basically you can find it from here for Blackboard students. If you enrolled at University of Alaska Fairbanks, and you should be able to find it from the Blackboard, and that located here. Okay, so that's the solutions for those problems. So let's see look at the first one. So this one basic problem state that we have the AB and BC of a different size, and the dimensions are given, and here the D1, D2 are symbols. So for this exercise, it asking the normal stress. Basically, all the normal stress must be less than or equal to 175 MPa. So that is this is what we know the allowable stress. Okay. So we want to determine the size of the D1, D2. So in this case, we from these translations, we want to know the sigma in shaft AB equal to how much that must be less than or equal to 175 MPa. The same thing, the stress in BC, they must be also less than or equal to 175. So that is the translations from the problem statement. And now let's look at how to solve this one. We can try to solve the BC first. So let me just abstractly pick up a section here. So let me pick up the sections and draw the free body diagram. This is a section I picked up. So this is a free body diagram. This is the given loading, 30 kilonewtons. So by action, reactions, and force equilibrium, so this is reaction force, and that's the 30 kilonewtons. Okay. So this is the force, and this force is normal to the cross sections we pick up. So this is the normal stress. So from here we can determine the normal stress. That is magnitude force divided by area. So the force equal to 30 times 10,000 Newton, 1,000 Newton divided by area. That is D. So pi over 4 D2 square. Say let me take the D2 is in terms of the millimeters. Okay, so that is a millimeter square. So this one must be less than or equal to 175 MPa. So under these situations, can you see that one is 3 divided by 175, and basically this is the unit MPa. Okay, so that means this one can be cancelled out from the both sides. So that means we can work on the numbers, and this one must be less than equal to pi over 4 D2 square. Okay, so from this situation you should be able to find out D2 must be then greater than equal to 14.77. that's the magnitude, and with the unit millimeter. Okay, and we look at the cross sections in AB. So let me pick this one. Okay, so the free body diagram for this case, let me see. So basically the free body diagram, this is the cross sections, and then here this is the free body diagram. I'm going to pick it up. Okay, so let me draw that one here. So here has the 30 applied, and here has the 43 kilonewton applied. So in total you should be able to see here should be 30 plus 43, 73 kilonewtons. Okay, so the stress here is in AB, that should be equal to 73 newtons, 1,000 newtons divided by the area. So in the similar process, 4 D1 square and millimeter square. And again, let me take the D1 as the internal unit millimeter. Okay, So this one must be less than or equal to 175 MPa. And the same reasons. Here, let me use different color. So this one equal to MPa, this MPa, so we can cancel out on the both sides. So from here you can see 73,000 divided by 175 less than equal to pi over 4 d1 squared. So from here you should be able to find out d1 is greater than equal to 22.6 and unit millimeter. Okay, so that is for these questions.